We have seen an example. We have also seen a code, how to do it from scratch. But there is one more thing left. Before I go to some predefined function or something like that, there is a very important thing in machine learning present, and that is what we call k-fold cross validation. Okay, this k-fold cross validation is a very powerful technique which is used to evaluate a predictive model, and you will see this technique very frequently in lot of different research paper, and because it allows us to estimate how good the machine learning model is behaving with the unseen data. So it's a technique. Now let's come to what exactly the technique is. The k-fold cross validation, in a simple sentence, if you say, it's basically divide the whole data set into some independent set, and each and every set basically we call fold. So k fold means whole data set divided into k sets or k subsets, you can say. Okay, now what basically we do, we consider k minus 1 subset as the training data, and the last subset, last means the last one which is left, as the test data. Okay, so just assume in this way, like we have a whole data set and divided into, say, assume that k is 5. Okay, so 5-fold cross validation, which is very frequently used. You will see this term 5-fold cross validation or 10-fold cross validation, not mostly use 5 anyway. So you will see that in many cases. So 5-fold means 5 pieces. Among 5 pieces, 4 pieces are used for training, fifth piece is for testing. Now which fifth piece? Definitely question come. It's not like that first four piece will be taken as training only. It is like, you can say that we are dividing the data set into 5 pieces. There will be training on the 4 pieces of the whole data set with 4 different times. I mean, in a different way. Like for example, first time we give the training on the first 4 pieces. The last piece we consider as a test data. Next time, and we will get some output. Since we are using the last one as a test data, we have some accuracy we get, right? Next time, what we do? We take some another 4 pieces as a training data, and the last one which will be left will be used as test data. So in this case, the train data set changes, right? And based on that, again you will get some accuracy. In as a whole, in this way, how many sets possible? Total 5 sets possible, 5 times, right? So the accuracy of the model that basically will be evaluated based on the average accuracy over these 5 different cases, and this is what actually written here. You see, the cross validation is a resampling procedure that evaluates machine learning model using limited data sample. First of all, whatever I have said in verbally, it's written in a proper way over here. That's the difference. So instead of evaluating the model only once, k-fold cross validation repeats the process multiple times to gain confidence in the model's performance. Multiple times means the things that I have just told you. And how this multiple times come? It comes here. The dataset is divided into k subsets or folds, just I said. Each fold is used as the validation set, while the remaining folds serve as the training data. Okay? The model is trained and evaluated k times. If k is 5, 5 times, just I told you. With each fold taking a turn as the validation set. So if fold 1 is validation state now, then fold 2 to 5 will be used as training data. Next time, when fold 2 will act as validation set, at that time fold 1 and fold 3 to 5 will be act as training data. So each and every set will have a chance to be a part of validation set once, I mean 5 times, and also a part of training data in some another 5 times, which in turn creates a definitely a gain confidence on the model's performance. So what basically I just told you, it looks something like this. You see here that we have a data set, we are splitting data into training test, splitting into k fold, using k minus world 4 for training, and the other fold is for testing. And that is what exactly the k-fold cross validation is given in this particular diagram. So now question comes that what is the benefit that we can get it from here, right? So remember, this k-fold cross validation is a very robust method for estimating the model performance compared to simple train test split. Why? Because in case of simple train test split, there will be a chance that the statistical behavior of the data that is present in the training data and the statistical behavior present in the test data may be different. What the statistical behavior mean? Say for example, a data, how you can define? I can define a data into two different forms. One is the mean of the data, like if you have a data set in the sense like say array of values. How you will define the data? You can define the data in terms of two things in a very basic way. One is mean and another is standard deviation, right? So if I say the mean is 2.5 and standard deviation is 0.7, that means the there will be some distribution of the data we have in this because by this mean and standard deviation, right? Assume that the training data has a mean something like this. If the mean of the test data becomes entirely different from the mean and standard deviation of test train data, then there is a chance that model may not behave correctly because based on the data set that you have given, the model has trained. The data set is given as 2.5 mean with standard deviation 0.7. So basically, the model has learned this distribution, not the other distribution. If you test the model with some other distribution of data, definitely model will not act correctly as our expectation. That's why we must ensure that the model gets a chance to get to get the correct you can say the distribution like the training data. So that's why here the k-fold cross validation works better, because you are basically giving chance for all the folds. So it's not like a biased anyhow that somehow you are giving the last few points only for testing. No, that's why there is no point of biasness. Second is that by averaging the performance of the matrix, we can obviously get some generalized idea, and also we can it helps us to get out from the risk of getting, as I told you, overly optimistic result due to random fluctuation in the single train test split. So all these things actually the reason of the difference of the distribution of train and test data, which is not expected. So we are trying to avoid using this technique. So now what basically we can do, like we can try to choose the what is the best value of k. I don't know. There's no surety that always five-fold cross validation will give the best result. Maybe sometimes tenfold cross validation gives better one, better model. Okay. And also there is a variation on cross validation. There can be stratified cross validation or repeated cross validation, that depends upon the distribution of the classes. Because if the class, for example, it's a binary classification problem, assume, and class 1 is very less than class 2, so naturally it will be better if we go for stratified cross validation, so that the class can be distributed evenly in the train and test data. And obviously, in case of, if we, since we already have Python, we can easily implement this k-fold cross validation from scratch, and we can use that. So these are some very important benefits of the k-fold cross validation. And you can say, like, what basically I have discussed verbally, the same thing written over here, right? Maybe more reliable evaluation or effective data utilization, based on, since we are giving the equal chance to all the pattern to be a part of the validation set means test set, and as well as we are giving the equal chance to be a part of the training set some other times. And also it helps us to prevent overfitting, because we are not giving any chance to, rely on a particular distribution of data. We are giving equal chance. So all these are basically effect of this dividing and giving chance to all. That's the thing. Okay. So this is what actually we call k-fold cross validation. And in future, when we will develop machine learning model, you will see there are many cases we have to follow, or it will be better if we follow a k-fold cross validation for claiming a good model performance with some unknown data. Is this clear, এই অবধি? Hello. Okay, good. So now let's do one thing. Let's go back. So now what we can do, we can go back to the code again. We can see how we can implement this k-fold cross validation from scratch. Okay. And then we will proceed with some very interesting thing, that is we call using actually the predefined functions and packages. Anyway, so we will see that. Let's go to the code. So this is an example code of implementing k-fold cross validation from scratch. Okay. Anyway, I'm just trying to make it easier for you. I'm just trying to explain it to you. See, just like a previous code that we have seen, we are using Irish data. Irish data is actually a very easy data to work with. So that's why when we teach, we use IDs dataset so that students can understand easily. So this IDs dataset is present. We can download it through a package, and that is the IDs dot equal to load underscore IDs is given, which is part of this scikit-learn dataset. See, so if you look into, if I just make it little more bigger for you, you will see that there is a package scikit-learn, sklearn dot datasets. From here, you can import load IDs function. This load IDs function will basically load the IDs dataset somewhere, and then this is, you can say, it's not a exact data here. The data part has the input and the target has the output. So finally, if you write this, it is basically unpacking the input and the output to x and y. That's all. Okay. So this x contain the all the full data set. Actually, there are total 150 rows of the IDs data set. 50 rows for every class. There are 3 classes, 50 rows per class, so 150 rows. Okay. And 150 output. Since in this case, my plan is to show you the part of k-fold cross validation from scratch. That's why here I have used a multi-layered perceptron classifier directly from a package. I am not going to implement the multi-layered perceptron classifier from scratch in this particular code. Okay, and that's why you see, after just splitting the data, the whole data set which is in x and y into two part, x test, x train and x test, y train and y test, using train test split is very common now for you, I hope. So one more thing I forgot to inform you, that when you are splitting the full data set into two parts, train and test, you have to specify how much data you want to put for test data set. Like, it's a 20% data you want to put for test, or 25%, or 30%, like that. That we can do using this particular uh, parameter, test underscore size equal to, if you put 0.2, it's 0.2 means 20% of the whole data set will be considered as a test data. So if you see the size of x train and size of x test, you will see it's 8 is to it's basically 5 is to 1. No, not 5 is to 1. It will be 80% here and 20% here. 4 is to 1. Yes. Okay. Anyway, so, and we are going to use this in the MLP classifier model, where we can easily, define the hidden layer size and all, the number of iterations, that is the epoch, okay, and all. So it's very easy to, I'm not going to create any MLP by myself. The package will create MLP for me. So now it seems to be very interesting for you, maybe because you don't need to write code. But anyway, there are many cases, you will see later, that you may not need to write code maybe from scratch, but you have to use some more interesting functions to create more complex models for complex problem. But I will suggest you that when it's a time of your learning, so it's better that you try to run the code, or write the code from the scratch, and once you will be you have enough knowledge to understand what's happening inside the box, then you can easily use the whole thing as a black box. Otherwise, you will be stuck somewhere, and there will be very difficult for you to come out from that. Maybe that's in interview, or maybe somewhere else. Anyway, so here I have considered k-fold, and you see I'm just going to do the training and testing everything, wait for every folds, and that is what happening here. You see, like this start index and end indexes is basically representing the part of the data which will be considered as the validation set. The rest of the part will be definitely for the train, and that is what is done here. You see, so the start index, end index has been used to get the data from the original data, that is from X train. It is giving X fold val. From Y train it is giving Y fold val. What does it mean? So this X train contain, say for example, if you see 80% of the data, it means 120 rows for training and 30 rows for testing. As simple as that, according to the division I have made here, right? Now in this 120 row, if you divide this 120 row into 5 different fold, in each and every fold how much will come? 24 rows, right? That means at a time 96 rows will be used for training and the 24 rows will be for validating how good the training is. Now which particular 24 rows? That is decided by the start index and end index. If you just try to print what exactly value of start index and end index is, you will see that it's varying. In every fold it is varying, and it should, because in the next fold that particular, not first 24, maybe the next 24 should be the validation set, other 96 rows should be the training set, and that is what happening here. So this line is basically taking from both x and y. I mean, this is input, this is the output, but the index remains should be remains same, right? That's why both in case of X train also we have start index to end index. For Y train also start index to end index, which is finally giving the validation set, and the rest of the part is for training, and that is what is happening here. Why concatenate? Concatenate because if you just try to imagine a array having 5 pieces, if you see the second piece is the validation, that means first, third, fourth and fifth are the training set. So you have to concatenate the first piece with the third, fourth and fifth piece. So concatenation has to be there. So that's why concatenation function is needed here, which is present under numpy package, and we get the x data. Similarly for the same we get the y for the same index, right? Now once we get this, we start training the model. We can do that with the data that we have seen, that is x fold train and y fold train. Once the model training done, then we can try to find out how good the model is by the validation set, which is the x fold val, which will give a predicted output, and already I have a actual output of the validation set, which is y fold val. So you can simply check the accuracy score by checking how close this y fold val and y pred val is. Remember, there is again a function for calculating this accuracy, this one, accuracy score. It's not a function that I have written. This function is present again we did sklearn package. You will see this one. So this sklearn package is going to be very vital for you during learning. You will see lot of things, you will find out lot of help you will get directly from this package. So you have to be very much habituated of using packages in near future. Okay. So once this done, then we just appending this and then printing this and something like that. And if you start, let's start it. If you run this, so it's done. And now this one is done. Now this one is done. Now this is created. And now if I just run this, you see it started working. Oh, okay, I got this. So accuracy of the first fold is this, accuracy of the second fold is this, and in this way it is showing. Okay. And then if you see the accuracy of the as an average looks something like this, the accuracy 0.53. So it's a 95.83% accurate. The model is. Now what you can do? You can try to fit on the entire data set if you want. Okay. And you can check with the, so it's created, it's running, it's done, and then you can check with the test data. See, this X test is not used for training anytime. The, see, here we are saying validation set, here we are using test set, and there is one more thing, train set. I've already used these three terms. Don't get confused with this validation set and test set. Both are used for testing. But the difference of these two is that validation set is used for testing the accuracy of the you can say the model which is under training. But the test set is used at the end when the model is finally completed, training of the model done, then only once the test set is used. But validation set can be used multiple times during training. For example, here, as you can see, for every fold we are changing the validation set, and we are using this validation set for predicting the model, maybe the half learned model, or you can say not the fully learned, but we are using this test set on the fully learned model, not the half learned. That is the difference. Okay. So this is a very simple code of the k-fold cross validation from scratch. Again, I am saying from scratch means there is a function again we can use in future. We will see how to implement this k-fold cross validation and many more using predefined functions. We will see that, and then maybe it will be more easier for you to work with the models. Okay. So now what we can do, we can start learning how we can utilize the different packages for creating these models.